Temperate rainforests used to extend up the entire west coast of Britain and Ireland, covering an estimated 20% of the total landmass. But centuries of deforestation for farming and commercial timber production have reduced these Atlantic woodlands to just 1%, meaning that these critically endangered habitats are more threatened than the tropical rainforests that we hear so much about. We've come to Snowdonia in North Wales, where a network of scientists, campaigners and conservationists are working together to protect and expand these critically endangered habitats and restore Britain's lost rainforests. In Britain, we love to complain about the rain. But it's this rain that has shaped the landscape and culture of the British Isles for millennia, including its woodlands. John Healy is Professor of Forest Sciences at Bangor University. Where are you taking us this morning?
We're going into the Coed Dolgarrog National Nature Reserve, which is the largest woodland national nature reserve in Wales. And we are in the hyperoceanic climatic zone, which is the zone that supports temperate rainforests. The whole of the British Isles is heavily influenced by the fact we're on the edge of the Atlantic Ocean. And we can see that manifest in what we're looking at here, the trunks of the trees.
Yeah.
They're covered in plants, lichens,
Wow.
mosses and ferns.
Yeah.
Some species of which really cannot tolerate prolonged periods of drying. And they're the sort of indicators of this oceanic rainforest kind of environment. In the UK and Ireland, the main rainforest indicator species are a certain small subset of lichens that are very, very intolerant of drought, that require moisture all year round. And they're the ones that only grow in these very wet rainforest conditions.
And it's these lichens that are the clearest indicators of rainforest. They have folk names like goblin lights, Merlin's beard, something out of Tolkien or Old English legend. But despite the ancient look of this landscape, on geological terms, the forests are relatively young.
20,000 years ago, we were under a deep ice sheet. So, I mean, how many generations of oak would there have been since we were under ice? It's not actually
that many.
Let's make a guess, and it is a guess, that oaks got back here, let's say 10,000 years ago. If they were reproducing every 100 years, then we need to divide 10,000 by 100,
right.
And we get to 100.
100 generations.
Sheer speculation.
Yeah, but I mean, it gives us a ballpark, so it's really, it's not, I mean,
it's not so many.
It's not so many.
Yeah.
Right.
We have here a map of Great
wow.
Britain and Ireland. The whole of these islands are in a wet part of the world. There's a huge gradient in rainfall, all the way from the wettest places in the northwest highlands of Scotland. We are up to sort of 2.5, 3 metres of rainfall. By the time you get to the east of Essex, you're down close to 500. So there's a huge rainfall gradient.
And is that just the proximity of the ocean, or the Atlantic?
It is, and the winds coming from the west, shedding their rain when they hit the first high ground.
I see.
You have these higher rainfall levels which fall within the modern concept and classification of the hyperoceanic zone that we now term temperate rainforests.
Why have we lost so much rainforest? Why are they dying out, and what is it that's stopping them regenerating?
Rainforests in many parts of the world, but particularly in Europe, have been massively deforested. And predominantly that is for food production. And so there's been a continuous pattern of deforestation, even by the times of the Doomsday Book, nearly 1,000 years ago. We had already depleted our forests to a great extent by then. Why are any retained at all? Well, it's partly because they're on the sites that would just have been too hard work to convert to pasture land. But also there can be some positives, although one might in some ways regret the fact that these woodlands were so much influenced and managed by humans. if they hadn't had that value, that purpose, they wouldn't still be here.
Mm-hmm.
So it was a positive reason for keeping them as well, where the materials that they could produce actually were so important to the local economy, but that in itself was a good enough reason.
Over the centuries, ancient woodlands have faced the axe, felled for farmland and later for commercial timber plantations, as landowners sought to improve the land by making it more economically productive. What was once a mosaic of wooded islands and open glades is now, for the most part, pasture in the west and arable land in the east. Woodland species still linger in hedgerows and along field margins, while fragments of forest survive on steeper slopes, rocky ravines and poorer soils. These western woodlands have long been recognised as ancient and ecologically rich. Traditionally, they were classified by their dominant tree species, but more recently, a new language has emerged. Writers and campaigners have begun to describe them as temperate rainforest, reframing these fragments as part of a globally rare and threatened ecosystem. It's a shift in perspective that has helped capture the public's imagination and is now driving a renaissance in their restoration. So how do we start to restore and protect these delicate ecosystems? A question Professor Healy has been working on for much of his career. The life cycles of trees and woodlands are tricky to study, largely because they long outlive humans. Their ecological rhythms are in a different league. Hard data on what to plant and how to plant is difficult because you won't get any results for decades. Forest ecologists like Professor Healy rely instead on looking at past land use to inform how, in the future, newly planted woodlands might live and respond to restoration, a practice called chronosequencing.
What we have to do, with lots of assumptions, is see if we can find examples of sites in sufficiently similar environmental conditions that started to recover or to be actively restored as rainforest at different times in the past. Mm-hmm. And so by moving from site to site and measuring the trees using sample plot methods, inventorying the biodiversity, recording the soil at sites that started to recover 10 years ago, 30 years ago, 50 years ago, we can build up that timeline of the rate of recovery.
John, this is this a path or a river though?
Well, it's a medieval trackway. It was known locally as the donkey track because I think people used it in the past to carry goods up and down the hillside on the back of a donkey. As you might be able to see underneath, it's a stone paved medieval pathway. But yeah, we are in the rainforest zone and drainage is restricted, so it's functioning as a stream right now. This is Acht Wicht, which translates as the wild hillside. We're halfway up the steep side of the Conway Valley, and it's a small area of land that's crisscrossed by these old medieval trackways. And as we'll see, it is full of the ruins of the old cottages of the community who lived here.
Oh, John, this is amazing. Now this looks like a rainforest.
Well, it does now, but 150 years or so, it was a series of farms. And this is a classic example of what was termed old field succession, because these are old fields. And whether it be in North America or in this country or elsewhere, it was one of the classic cases where we began to understand this long-term recovery process through natural mechanisms. The natural succession is leading to the recovery of all components of the temperate rainforest system, the trees, mosses, lichens, ferns. The whole forest ecosystem is recovering together. Well, here we are, Russell, one of the older cottages.
It's all a bit Indiana Jones, isn't it?
It certainly is, yes.
With the lianas and the boulders and everything. Wow, gosh.
Yeah.
Oh,
the forest has swallowed up the habitation, yeah.
So when do you think the last family left here?
It would have been in the early part of the 20th century, possibly about 1910, that the last families finally left this area. It was a community of 20 or so separate cottages, an isolated community living on this wild hillside.
So what does this place tell you in terms of the health of current rainforests in the UK and the potential of them to re-establish in the future?
Well, a term that's often used to address that kind of question is resilience. There's no future for existing temperate rainforests unless they have that resilience, and there's no point creating new ones if they're going to be very vulnerable to being lost for one reason or another. So while an existing ancient temperate rainforest, its capacity for recovery is inbuilt, what about the capacity of rainforests to recover after some completely different land use like agriculture? Well, a site like this one gives us real encouragement that that potential for recovery, even after centuries probably of farming, is here. They have that capacity, that key component of resilience.
There's birch, there's oaks, elder, some willow down there by the water. I mean, this is incredibly diverse woodland. You've got to remember, it's not just about the trees, you know. We've got the mosses and liverworts, we've got the ferns. This is a regenerating rainforest, and it's happened in just 100 years. It's sites like the wild hillside farmsteads that prove regeneration is possible across the temperate zones of the UK. The remaining pockets of woodland can expand, and previously cleared land can recover. So we know that temperate rainforests will regenerate naturally, given the right circumstances and plenty of time. But with temperatures rising and biodiversity in steep decline, the question is, can we save a bit of time by kick-starting rainforest regeneration and lending Mother Nature a helping hand? I've come to Pembrokeshire on the Atlantic coast to meet a group of researchers who are doing just that. Adam Dawson is the site manager for the Wildlife Trust of South and West Wales.
So this bank here is ancient woodland. As we go up, a lot more of it is secondary woodland.
He wanted to show me a patch of abandoned pasture land that they've just bought.
And I mean, what we're doing here with the rainforest restoration, I don't think anybody would really be naive enough to say we're planting a rainforest. We're planting a woodland,
Right.
and hopefully it's in the right place, it's got the right neighbours, so over time it will become a rainforest. We're starting a 500-year journey by planting trees now. You know, in many ways it's quite a dark time to work in conservation because there are colossal species declines, you know, there are all sorts of threats to our native wildlife. And I think the best that we can do is to create refugia. Those refuges become nodes, I guess, and then you create linkages between them.
Right.
And you know, with the Wildlife Trust, that's very much what we've been trying to do here in the Gwaun Valley.
Nice. This is great, isn't it?
That's an amazing spot, isn't it? One of the things that people miss if they don't know about temperate rainforests is that once it's under UV light, which is actually how an insect sees the world, and you just see it like a tropical coral reef or something like that, oranges, reds, you know, blues, all sorts of colours.
As Adam said, under ultraviolet light, we begin to see lichens as insects do. A startling technicolor world more reminiscent of a coral reef than the muted greys and dusty greens that we're used to. Lichens are not a single organism, but a cooperative partnership between a fungus and an algae, and like coral, they're known as symbionts, living systems formed from the coming together of at least two different species.
What's really apparent is that with this new fashion for temperate rainforest is how little we really understand, because we just haven't looked. even with the lichens, I mean, if this is a coral reef, we are like a bottom dwelling fish. You know, that we're not really looking up, or we haven't been previously. And so much of what's going on in a temperate rainforest and in a tropical rainforest is happening in the canopy.
In the canopy, lichens, mosses, ferns and lianas, collectively known as epiphytes, create an entirely separate, suspended ecosystem. Year-round rain and mist allow plants such as the polypody fern to grow on the tree branches, capturing moisture and nutrients from the air. And over time, these communities accumulate organic matter, building layers of biomass that stores carbon and retains water, creating the perfect conditions for other species to take hold.
We're now coming on to Trellwyn Fach.
Trellwyn Fach.
That's well said.
So this would have been grazed land? This would have been
this, until 2 years ago, this was all grazed. Overall, this site is 49 hectares, and within that, we're going to be planting 50,000 trees.
Why not keep this land producing food?
Agriculture and woodlands only got separated after the First World War. About 100 years ago, because of the strategic need for timber, the Forestry Commission was established and animals started to be excluded from woodlands. If you look back in history, throughout medieval times, agriculture and forestry went hand in hand. Animals love eating tree leaves, and cutting tree hay, shredding trees was all part of the agricultural year to get forage for your animals.
So you're not just clearing away farms and planting trees. It's about trying to integrate them together.
Exactly.
Once the trees are established, Adam and the team plan to reintroduce cattle to the site. Browsing livestock in woodlands is one of the oldest forms of agriculture. It's a system known as silvopasture, where farmed animals create glades and grassy areas within a wood. They serve as proxies for extinct megafauna like the auroch, the wild ancestor of modern domestic cattle. They browse and disturb habitats, keeping woodland in a healthy, constant state of change.
This leaf here is Lesser celandine. It's one of the early signs of spring, and it's very common in woodlands. And what this is telling me is that once we plant the trees, some of those woodland species are already present. So as soon as the canopy starts to get established, we'll see that ground flora moving into our newly planted woodlands really quite quickly.
The restoration team have an unexpected ally for whom tree planting is a way of life.
I've put this basket in the tree and I've been filling it up with acorns to feed the jays. And what I'm doing is I'm paying the jays in acorns to plant trees for us. So where they spread the acorns all around this site and bury them, they'll hopefully forget some of them, and the ones that they forget will grow on into some of our trees.
And so this empty basket here was full of acorns?
So I filled that up. This is the 4th time I filled it up. So each time I come, I'm probably putting about 500 or more acorns in there.
Wow.
The reason I've got the camera trap is to make sure that it's actually the jays that are eating them and not squirrels or mice or something like that, which it may be. We'll find out when I get this back. But considering this basket was full and I've just got a handful of those shells, I'm optimistic that the rest of them have been spread out around the site.
Right, amazing.
I think you learn so much by observing what nature does.
And what it does is pretty amazing. Equipped with a specialised throat pouch, the Eurasian jay can carry up to 6 acorns at a time, bearing as many as 11,000 in a single season. While most are cached or stored for survival, thousands are inevitably forgotten, making this bird one of the most effective foresters in Europe and a welcome partner in Adam's mission to reforest the land.
So this piece of rock has been here for at least 4,000 to 6,000 years.
Wow.
And so people have been living and working in this landscape that long. So this is the same stone as the blue stones that you'll get in Stonehenge.
And the lichens that cling to it today are yet another indicator that this land will be perfect for rainforest restoration.
The farmhouse here was inhabited as recently as the 1980s.
Really?
That was the last time that people lived here. So within 40 years, it's gone from a habitable dwelling to a ruin. But I mean, what we don't know is what condition it was in before then. And in a way, what we're doing by planting these trees, some would say it's going backwards, but you could also see it as a return. So it's like the closing of a circle. And the landscape that we hope to create will look very much like the landscape at the time that that standing stone was first erected. You know, it'll be like that Neolithic landscape that first drew people to come and live here because they saw it as a place rich in resources.
It's amazing, isn't it? It's a great illustration of how rich this habitat is. I mean, this is just a little enclave of that temperate rainforest, but the rest of the site extends all the way around here, and it's mostly just that old farmland, the old pasture. But this is just a little window into what it could become. You know, on this tree, it's winter time, there's no leaves on it, and yet it's still supporting all this life. The mosses and lichens and these polypody ferns growing up in the branches. You can see that the tree, it's not the whole story. The trees are kind of architecture for all this other life. These trees and the plant life they support are incredible carbon sinks, but the exact amount of carbon that is sequestered is still not known. Sophie Higgett, a colleague of Professor Healy's from Bangor University, has teamed up with Adam on the Pembrokeshire site to monitor how slow-growing hardwood locks away carbon over time.
So here we've got a little bundle of cell-grown hawthorn trees. So you can see the spikes on them.
In all weathers, Sophie is monitoring how much carbon is sequestered by trees, but also how much is released from the soil when the ground is disturbed.
A lot of the tree planting has a really big focus on carbon, but one thing we're really interested to know more about is what happens to the below ground carbon when you tree plant, because there's such a huge store there. But when you come in and are putting trees on a site, you're digging it up, you're disturbing it, you're changing those dynamics. So it could be that planting trees on a site, it's like a net gain. You'll get just adding above ground carbon to your below ground carbon. But it also could be that you're disturbing the ground and maybe losing some carbon from the soil. So it's really, really important in terms of this overall goal of storing carbon to have a real clear understanding of how that works. So this is the carbon dioxide analyzer that we use for looking at the carbon dioxide that's being emitted from the soil. So you can see that's a chamber that slots into the collar of plastic.
Right, it goes in there.
Exactly.
What's that noise?
So you can hear, it's heated up inside to about 50 degrees, so you can hear the temperature sort of going.
Okay.
And then if we press go, it starts pumping gas through. So the first thing you do is sort of hold it up in the air to flush the chamber. So if you grab it by the end and hold it up like that, it's showing you how much sort of CO2 it's detecting in the air now around us. So around 420, up or down a little bit.
427 to 428 parts per million is the current global average reading of carbon dioxide in the atmosphere. So even on a windy hillside in Wales, 415 is very high. To put this in perspective, the pre-industrial carbon dioxide level was 280 parts per million, and 350 parts per million is widely accepted as the maximum safe level to avoid irreversible climate change.
And then when it beeps, we stick it on top of the chamber here. So pop it down and try and get like a nice seal around the edge so there's not any massive gaps. And then what it starts to do is record the CO2 that's being emitted. So this is the concentration of carbon dioxide that's building up inside. If we find that something here is creating an increased amount of CO2 and carbon being lost from the soil, if that was scaled out across an entire hillside, you can imagine there's potentially tons of carbon lost from the soil over years.
So I heard the beep.
Yeah.
Is it what's happening now?
Yeah, so the beep means it's finished measuring. It's picked up an increase in 23 in the chamber, so 23 parts per million. So that's entirely what's been emitted from the soil whilst we've been having a conversation. So that's happening all around us.
That's amazing, isn't it? Yeah, completely invisible to the naked eye. There's activity happening right beneath our feet. Using LiDAR surveys of mature woodland, the twisted branches and canopy-level plants can be measured and mapped, helping to build a more complete picture of the true carbon value of temperate rainforests. This work forms part of the Wildlife Trust's UK-wide temperate rainforest restoration project, supported by £38 million in funding from Aviva. The long-term aim is to understand these ecosystems and restore them at scale.
For me, being part of a project that's directly helping contribute knowledge towards the climate and biodiversity crises, I find it really fulfilling. And part of me also just really enjoys being out in the windswept hills in January.
And in the locations that are proven to be best suited for slow-growth trees, new forests can be rolled out across the temperate zone.
Potentially we could create a woodland habitat network that stretches right the way across Pembrokeshire, and in time maybe all the way up into mid-Wales. You could be walking under woodland cover for 6 or 7 days, just coming out for a view.
The term temperate rainforest is one that I'd heard a long time ago, and it was always associated with the big forests of the Pacific Northwest and North America. And the idea that that same terminology would apply to some of our Atlantic woodlands in this country, it is amazing how that's captured so much of the imagination, and particularly in the context of the twin emergencies of climate change and biodiversity.
So we came here to Wales in search of lost rainforests. And it seems, though much denuded and fragmented, it's not the rainforests themselves that are lost so much as the idea of them. Evocative words like rainforest have the power to change the world, so that a damp woodland becomes a magical place of wonder. And it reminds me of that old adage, if you want to make small changes, change the way you do things. But if you want to make big changes, change the way you see things.